Next topic is diameter form of equation of sphere. So the general form of the equation of sphere is what? X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. This is the general form, or x minus a bracket square plus y minus b bracket square plus z minus c bracket square is equal to r square, where ABC is the center and r is the radius. Is the general form. Now we have to find the diameter form of the equation of sphere. So straightforward question that the find the equation of sphere whose diameter having n points x1, y1, z1 and x2, y2, z2. These are the n points of the diameter. That is now we have to find the equation of sphere. Let P x y z. So draw this figure. Will show A x1, y1, z1 and B x2, y2, z2 as n points of the diameter of the sphere. That is, obviously this diameter means is the chord passing through the center of the sphere is diameter. Okay, so this is the chord passing through the center of the sphere. So it is the diameter of the sphere whose n points are A x1, y1, z1 and B x2, y2, z2 are the n points of the diameter. Now let P x y z be any point on the sphere other than A and B. We take P x y z as any point on the sphere. Join this AB, AP and PB. Okay. Now the plane determined by APB, that is this triangle, this plane. If we cut this sphere by this plane, then we have the great circle. So the plane determined by APB passes through the center of the sphere, because this line AP passes through the center C. So if this plane passes through the center of the sphere, and so this section is a great circle. So section of sphere by any plane is a circle. The section of sphere by plane is circle, and this plane passes through the center of the sphere. Therefore, it is a great circle. The section of this sphere by using this plane APB is a great circle. So the next topic is show that the section of sphere by plane is circle. Okay. So if you cut the sphere by plane, then the intersection part is the circle. That is, the if you cut the sphere volleyball by using plane, suppose, then it divide into parts. But what is the intersection part? Intersection part is the circle. So if we take the section of sphere by plane, then it is a circle. And this circle, the section of this sphere by using this plane APB is a great circle. Great circle means what? The largest circle. Okay. So its center is a C. The circle of the center is what? Is a center of the sphere is the center of the circle. So because this plane APB passes through the center of the sphere, because this AP line pass through the center of the sphere, and therefore this section is a what? Section of any sphere by plane is a circle. And in this theorem, in this example, this APB, this circle, this plane passes through the center of the sphere, and therefore the section by using this plane of this sphere is a great circle. This is great circle. That is the circle having center C as a center C of the sphere as a center of the circle. And now the angle made in the great circle, semicircle, is what? Is a right angle triangle. So angle APB is what? Is 90 degree. Is the angle is the 90-degree angle, because if we cut this section, then this is the now circle becomes circle, and this angle APB is the angle made in the semicircle. And you note that the angle made in the semicircle, every angle made in the semicircle is what? Is right angle triangle. And so angle APB is 90 degree or pi by 2. And therefore the line AP is perpendicular to line PB. The line AP is perpendicular to line PB. This point is B. And what are the direction ratios of line AP? So the coordinate of A are x1, y1, z1, and the coordinate of P are x, y, z. And therefore the direction ratios of line AP or PA is what? X minus x1, comma, y minus y1, comma, z minus z1. And the direction ratios of line PB or BP are what? The coordinate of P are x, y, z. The coordinate of point B are x1, x2, y2, z2. And therefore the direction ratios of line PB are what? PB are x minus x2, comma, y minus y2, comma, z minus z2. Okay. And then by condition, these two lines are perpendicular. AP and PB are perpendicular. So by using condition of perpendicularity, what do we have? What is the condition of perpendicularity of the two lines? That is the if the first line has the direction ratios A1, B1, C1, and the second has the ratios direction ratios as A2, B2, C2. Then condition of perpendicularity is what? A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So by using the condition of two lines to be perpendicular, we have x minus x1 into x minus x2, that is a1 into a2, plus y minus y1 into y minus y2, that is b1 b2, plus z minus z1 into z minus z2, that is c1 c2 is equal to 0. And this is the equation of sphere in diameter form. So this is very important question. The example on this is also important. So what is the example? Find the equation of sphere whose diameter is AB, and the coordinate of AB are 2, minus 3, 1, and B is minus 1, minus 2, minus 3. That is what is given. We are given x1, y1, z1 and x2, y2, z2, the coordinate of the end points of the diameter. So these are these coordinate x. So this is x1, y1, z1, and this is what? X2, y2, z2. Compare. And then the equation of sphere is what? The answer of this question is what? The equation of required sphere is x minus x1, that is x minus 2, y into x minus x2, means x minus minus 1 become plus 1, then plus y minus y1, that is y minus minus 3 become plus 3, and y minus y2, that is y minus minus plus 2, plus z minus 1 into z minus 4, z minus 4 is equal to 0. So simplify this, square of this multiplication of these two bracket, we have 4 terms, x into x, x square, plus x minus 2x, right here minus 2x, plus not plus, minus 2. So minus yes, my x square, then minus 2x and plus x become minus x, and minus 2. We have 4 terms. The addition of minus 2x and plus x is minus x. Similarly, multiplication of these two terms is what? Y square plus 3y and plus 2y become 5y plus 6, and then multiplication is z square minus z and minus 4z become minus 5z, and the minus 1 and minus 4 multiplication plus 4, and this final answer is what? X square plus y square plus z square minus x plus 5y minus 5z, and the constant term is plus 8 is equal to 0. This is the answer of this example. So the second question is same, but wording is different, that find the equation of smallest sphere passing through these 2 points. So we have to find the equation of sphere whose diameter is 220 and 202. That is whose end points of diameters are 220 and 202. So we have to find the equation of sphere whose diameter is this. If we find the equation of sphere whose end points of diameters are these two, then it is a smallest sphere passing through that 2 points. So if we write the different form of this example also, then what is the another question? Find the equation of smallest sphere passing through the point A 2 minus 3 1 and B minus 1 minus 2 4. So one and the same, that find the smallest sphere passing through 2 points, or find the equation of sphere whose diameter has n points as 220 and 202. So same question, same answer, right? Same answer. This is problem for assignment. That is right. X, the equation of smallest sphere passing through these 2 points is what? X minus 2 into x minus 2 plus y minus 2 into y minus 0 plus z minus 0 into z minus 2 is equal to 0. So next topic is what? Section of sphere by plane. Obviously the section of sphere by plane is circle. That is, if we cut the sphere at this at this place by using plane, then we have this is the circle as the intersection of this plane and sphere. So show that the section of sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0 by plane x plus by plus cz plus d dash is equal to 0 is circle. So the notation, the equation of circle, if you observe the equation of plane, then it is x plus by plus cz. There is no plus d because already d notation is in the equation of sphere. So in order to different notation, use d dash or d1. So we have to show the section of this sphere by this plane is circle. So let's see with the center of the sphere and A be the point on the sphere. Suppose P is the C is the center of the sphere and A is any point on the sphere and plane. What is the point A? A is the point on sphere as well as plane. That is the point of intersection. Suppose this is the plane. This is the plane at which by using that plane take the section of the sphere. So suppose this point A is what? The point of point on plane as well as sphere, the point of contact, point of intersection, one of the point of intersection. Then join CA, join this CA, also PC and PA. So then let CP is, then CP is perpendicular to, CP is perpendicular to or normal to plane 2. Suppose this, write this equation of sphere, numbering it as 1, and the ax plus by plus cz plus d dash is equal to 0 as equation number 2. Then what happens? CP is what? Is perpendicular to plane, means is normal to the plane number 2, to this plane, because the plane is at this place, and this CP is now perpendicular to plane, means is normal to plane, is normal to the plane. CP is perpendicular to PA also, this PA like PA. And so in right angle triangle CPA, this is the right angle triangle, this angle P is 90 degree. What we have? CA square, that is the hypotenuse square, is equal to CP square plus PA square by using Pythagorean theorem. Pythagoras theorem that hypotenuse square is what? Is equal to the addition of squares of the remaining two sides, CP square plus PA square. Okay, and therefore PA square is equal to CA square minus CP square, and this CA is radius of the sphere. CA is the radius of the sphere, and so it is fixed or constant. The radius of the sphere is fixed or constant term, and CP is what? CP is this, the distance of the point C, center C from the plane. It is fixed because the plane is placed at this place. So this CP is also constant, and therefore CA is constant, CP is constant, and therefore PA is also constant. PA square is constant because both these terms are constant or fixed, means PA square is constant, and PA square is constant. Therefore PA is constant. This PA is constant, and if this PA is constant, and therefore the locus of point A is circle with center P, because this PA is constant, and if we move this point, rotate this point A, then we have a circle of radius PA with center P. So the locus of the point A is a circle, and therefore the section of sphere by plane is circle, because this A point is what? Is the point of intersection of plane and sphere, and its locus means the section of sphere by plane is circle. As why? If this PA is not constant, then it is not circle, but if this PA is constant or fixed, and therefore if you rotate this point A, then we have the circle, or the locus of the point A is what? Is circle, and therefore the section of sphere by plane is circle. Equation of sphere passing through the circle of intersection of sphere. The next point is this. So this is also important. The equation of sphere passing through the circle of intersection of sphere and plane. The intersection of sphere and plane is circle, and now we have to find the equation of sphere passing through the circle of intersection of this sphere and this plane. So if we denote the equation of sphere by S, and if we denote the equation of plane by V, then S plus lambda V is equal to 0 is the formula to obtain the equation of sphere passing through the circle of intersection of sphere and plane. So what happened? The section of this the intersection of sphere and plane is circle, and now we have to find another sphere passing through this circle. So it is what the formula is: S plus lambda V is equal to 0, where lambda is constant. Okay, so this is the similar topic to the topic that equation of plane passing through the line of intersection of the two planes. Suppose U is equal to 0 and V is equal to 0 are two planes, then what is the equation of plane passing through the intersection of these two planes? That is the equation of plane passing through the line of intersection of the two planes. U is equal to 0 and V is equal to 0 is what? U plus lambda V is equal to 0. So this topic is similar to the previous topic. What is that? The equation of plane passing through the line of intersection of the two planes. So the topic plane, in the topic plane, find the equation of plane passing through the or containing the line of intersection. So this is, yes, this is the system of planes. That is U is equal to 0, that is U is a1x plus b1y plus c1z plus d1 is equal to 0, and v is a2x plus b2y plus c2z plus d2 is equal to 0. Then U plus lambda v is what? Is the equation of plane passing through the line of intersection of these two planes. U is equal to 0 and v is equal to 0. Is the system of planes, means the if we change the value of lambda, we get different planes passing through the line of intersection of these two planes. The intersection of two planes is line, and the another plane passing through that line is what? U plus lambda V is equal to 0. Similar topic is now here, that the equation of sphere passing through the circle of intersection of sphere and plane. The intersection of sphere and plane is circle, and we have to find the equation of sphere passing through that circle. If the equation of sphere is denoted by S, here is the topic, yes, this is the equation of sphere, that is the LHS of sphere, and V is equal to 0 is the equation of, now V is equal to 0 is the equation of plane, and the intersection of this sphere and plane is circle, and the what is the equation of sphere passing through this circle is S plus lambda V is equal to 0. S is the equation of sphere and V is the equation of plane. So S plus lambda V is equal to 0 is the formula to obtain the equation of sphere passing through the circle of intersection of sphere and plane. So we will see the examples on this topic in the next lecture.